Finally, statisticians are interested in knowing if there's any data values in your set that have a great influence on your center of tendencies, or your mean, median, mode, or your spread of your data. And these things are called outliers. So what we're going to be doing is we're going to see if we can find any outliers in our data that would greatly influence either our mean or our spread of the data. In order to do this, what we're going to do is we're going to calculate interquartile range. So the difference between third quartile and the first quartile is called the interquartile range. Now this is going to be what's going to help us calculate how to find any outliers, data values that lie way outside of the data set. The interquartile range contains about 50% of the values. Before deciding on which measures best describe a set of data, check the data for outliers. An outlier is an extremely high or extremely low value when compared to the rest of the values to the set. To check for outliers, look for the data values that are beyond the upper and lower quartiles by more than 1.5 times the interquartile range. Okay, so here's some quick things. Interquartile range is nothing more than Q3 minus Q1. If we take the interquartile range, multiply it times 1.5, it will tell us the size of the values that we don't want to exceed. If we get above 1.5 times the interquartile range, then that number is going to be an outlier. It's going to be too high for our data set, and we should disregard it, or at least take into account that that data point is clear outside the rest of the data values that we're looking at. Okay, so what I'm going to do is I'm going to plug these numbers in the calculator, and I'm going to come right back and we're going to finish this problem. So hold on. Okay, I'm going to show you the data that I put into the calculator. We added to list. I happen to put these 22 pieces of data into list 2 just to show you that you can use something other than list 1. But there should be 22 pieces of data, and hopefully I typed them all in correctly, into the calculator. We're going to run our one variable statistics, so we're going to calculate a one variable statistics on list 2. Now if yours says list 1, you simply hit your second 2, that gets your list 2 in there. We did not use a frequency list. Like I said, our lists are relatively small, so we don't mess with it. And we calculate our one variable statistics. Okay, the first thing we want to do is we want to calculate our interquartile range to see if we have any outliers. So we're going to go down to Q1 and Q3. We're going to find the difference of these. So we're going to take Q3 minus Q1, and that'll be our interquartile range, which our numbers are going to be 25 minus 15, which gives us an interquartile range of 10. So between 25 and 15, we have a range of 10. That's where 50% of our data is. And now, what we're going to do to help us identify our outliers is take the interquartile range and take it times 1.5. So now, take our 1.5 times 10, and that's going to help us find our outliers, which is 15. This is the number that we add on to and subtract from our Q first and third quartile. So we're going to take Q1 and we're going to subtract 15 from it. And then we're going to take Q3 and we're going to add 15 to that. So our first quartile range was 15. I'll just get that data back up here on the calculator so you know I'm not making that up. Our first quartile was 15. In order to find an outlier, we have to go 15 below it. So it's 15 minus 15 equals 0. Well, we don't have any values that are below 0, so there's no outliers below the lower quartile range. So then we'll take our third quartile value. Our third quartile value is 25. We add 15. And if we have an outlier, it's got to be a value higher than this, so 25, 35, 40. 40 would be the edge of our outliers. Do we have any values that are higher than 40? So as we scan our data, we know that the 65 is larger than 40, so that is one piece of data one data value that is above. So 65 ends up being an outlier to this data set. It's way beyond the rest of the set. So an outlier in this case is 65. So that's how you figure out whether you have any outliers in your data set. And you could have some above and some below, but this data set only has one outlier of 65. So we've identified the outlier. Now what it wants us to do is use your graphing calculator in the data and put in our values with the outlier and without the outlier. So we want to see how much of a difference does 65 make to our mean and our median and our mode and our range and standard deviation. So we've already got all this data in here. This time it is with the outlier. I already have 65 in it, so all I got to do is get the data and write it down and record it here so we have all of it in our set. I'm just trying to make sure that I can see everything here. Oh, lost it. I was going to shrink it if I could. Okay, so the first time it is, get my eyes on it, with the outlier, and that's the data I have in there. What is the mean or the average with the outlier? And it's 22.5. So we'll put 22. I better use a different color. What was the median? So I got to scroll down and find the median. The median was 21. The mode, the calculator doesn't necessarily tell you the mode, but we can figure out which one occurs the most often here in a second. The range has got to be the difference between the max and the min, so that's 65 minus 10. That is 55 for the range. And standard deviation, the only thing we have to decide on standard deviation is this population or is it sample. Since it looks like a reflection of the entire class, we're going to use the population standard deviation, which is sigma. So it's this one here, sigma x, which is 11.21. And then we'll calculate our mode here by looking at our data set and see if anything occurs more than once. 15 occurs twice, 3 times, 4 times. So 15 occurs 4 times. 12 is not. I don't think we can beat 15. 25. I got 1, 2, 3, 4. Oh, 25 has 4 occurrences. 27 can't compete. 10, 16, 18. 18 is 1, 2, doesn't beat 4. 30, nothing. 35, no, not anymore. 22, I don't think we can beat those 4 occurrences. So these two, 15 and 25, both occur 4 times. So this is called bimodal. So it has 2. 15 and 25 are the modes. Now we're going to do it without the outlier. So now what we do to our data set, we go to our calculator and we simply remove from our data set our outlier, which was 65. So go to your stat, edit your list, and that was in list 1, or I'm sorry, list 2. I'm going to find 65 in the data set, and we're going to eliminate that one. So we're going to delete that 65. And now we should be down to a total of 21 pieces of data. And if I come back up here, that's accurate. And we're going to run our one variable statistics once again. We're going to calculate one variable stats. It's on list 2, and we're going to calculate. And now what does that do to our standard deviation and our, to our mean, median, mode, and so on? So if we do that, our mean now is 20.52. Our median, if we come down and look at the median and quartiles, the median is 20. The mode shouldn't change. It should stay 15 and 25, so we didn't remove any of those. Our range should be our difference between our max and our min, so now it's 35 minus 10, which is 25. And our standard deviation, again, go back and get your population standard deviation, which is sigma x, is 6.46. So what happened when we remove the outlier? As soon as we remove the outlier, our data becomes much more compact. Our average, or our mean, goes down. We don't have as big a spread there. Our median goes down. Our modes didn't change, but the big differences are in your range and your standard deviation. By removing that 65, which was way away from the rest of the data, it lowers the range and makes the data more tightly compacted, so the spread isn't as large. And standard deviation says most of your scores are only about 6 units away, or 6 in this case, I think it was minutes, away from average. So on average, students took about 6 minutes per problem to do their assignment class, where that when you add that 65-minute person in there, how its standard deviation is quite large. So looking at your data sets with and without the outlier and showing you just how much the outliers can change your data.